Hi everybody, this is going to be some selected problems from the Unit 9 test review. Our first question is the slope-filled questions, which these questions are really just kind of a trial and error basis. I usually kind of look at the graph to see if I see anything interesting happening, like I see this has a bunch of zero slopes here, and I see zero slopes here, so those might be some starting points for me. Other than that, I also try like maybe one in each quadrant just to see if I can rule some out. So for example, at 0, 0, I see that I have a zero slope here. Remember, these are all slopes. So I'm going to see if I can rule out any. Well, 0 times 0, 0. All of these would give me a 0 answer if I plugged in 0 for x and y. So that point didn't help me any. So let's see what else I can try. Well, since I noticed that there's a 0 here, this would be 1, 1. Each of these tick marks are generally 1 unit, and I can also see that this ends in 5, so 1, 2, 3, 4, 5, so it's definitely true. So when I look at negative 1, 0, that also has a 0 slope. I wonder if that will help me eliminate any. So let's see, that would be 0, that would be 0, that would be 0, that would be 0, minus 1. Okay, this one would be negative 1. So that ruled out that one. And then this would be also 0. So that didn't really help me a whole lot. All right, so now I'm just going to try the quadrants. At 1, 1, there is a positive slope. So I just need to check to see that I'm getting a positive number here. So 1 times 1 would be positive. 1 times 1, minus 1. Okay, 1 times 1 is 1, minus 1 would be 0. So I can rule out that one now. 1 times 1 is 1, plus 1 would be a positive slope. So we can't rule that one out. 1 plus 1 is 2, 2 cubed would be a positive number. All right, we'll rule out one more. Let's see, what about negative 2, negative 1? So negative 2, negative 1 has a positive slope. Okay, well, a negative times a negative would give me a positive, so that one's still good. This one would be a negative times a negative. So negative 2 times negative 1 would be 2, plus negative 1 would be positive, so that one still works. This would be negative 2 plus 1 is negative 1 cubed. Well, that would be a negative, so I can rule that one out. I need one more point to choose. What about, it's also interesting that negative 1, negative 1, positive 1, negative 1, positive 1 has a 0 slope. Maybe I can rule out something with that one. Let's see. Negative 1 times 1 would be a negative slope. Yay! It's not 0. Negative 1 times 1 is negative 1 plus 1. That's 0. Oh, but that's my last choice. Finally ruled it. So you can see it just takes slow plugging in points to see till you finally have eliminated the ones that are left. Okay, number 2. If dy dx equals x squared divided by y and f of 0 equals negative 4, find the particular solution to the differential equation. So we're finding the particular solution. That means we're solving for c using this initial value, and we're trying to find the solution of f of x or y. So step 1 is to separate our variables. We want to get y's on the left, x's on the right. So I'm going to multiply times y. I'm going to multiply times dx. So when I multiply that, I multiply that. Okay, now I have all my y's on the left, my x's on the right. I am ready to do the antiderivative. So antiderivative of this would be raise it by 1, divide by it, raise it by 1, divide by it, and then plus c. My goal is to now find c, so I'm going to use my initial value of 0, negative 4. Negative 4 squared is 16, divided by 2 is 8. 0 cubed divided by 3 is still 0. So my c is 8. Okay, so now I know the equation. It is y squared over 2, x squared over 3 plus 8. So that is the particular solution. My final goal is to get y by itself, to find an equation solved for y. So I first want to get rid of this denominator of 2, so I'm going to multiply everything by 2 since it's being divided by 2 currently. So that leaves me with y squared. Multiply this by 2, I get 2/3 x cubed times 2 would be 16. Okay, to get rid of a square, we need to square root both sides. Remember, every time you square root, though, you should always do plus or minus. We don't know which version it's going to be. So in order to see which version it is, we need to do our test with our point, 0, negative 4. So I'm going to test 0, negative 4 to see if I need the plus or minus. So when I plug in 0 here, I get 0 plus 16. That's 16. Square root of 16 is 4. So in order for this to equal negative 4 over here, I'm going to need that negative. So my final answer is negative square root of 2/3 x cubed plus 16. Okay, the next two are pretty similar, so I'm going to skip that, but you can find the answers on my key online. I'm going to skip to number 6. All right, this is another, we're finding a particular solution, so same kind of problem, I just wanted to work a different type. So my first goal is to get y's on the left, x's on the right. So I'm going to divide by y and multiply dx. Now I'm ready to do the antiderivative because I've separated my variables. Remember, this is just 1 over y. So whenever we have 1 over y, that antiderivative is always natural log of the absolute value of y. I'm going to raise it by 1 and then divide by it, which just leaves me with x squared. Raise this by 1 and I just get x. Don't forget your plus c. Now we're going to find c by plugging in the coordinate 3, 1. Three squared is 9 minus 3 plus c. Okay, so natural log of 1. So remember, the answer to a log is its power. So e, that's the base here, e to what power is 1? Well, that's going to be 0. 9 minus 3 is 6. So c is going to be negative 6. Okay, so now I am going to write my equation with c plugged in. The final step is to get y by itself. I want to get rid of this natural log. To undo a natural log, we have to e to that power. So I'm going to raise this to the e power on both sides, so that this e will cancel that ln out, and I'm just left with y. And then this is all e to the x squared minus x. This is all now an exponent here. My final step, these absolute value bars mean that this could be plus or minus here. To figure out if it's going to be plus or minus, just like we did on the last problem, is I need to test my initial value again. I need to test 3, 1 to see if I need the positive or negative. So if I plug in 3 right here, 3 squared is 9, minus 3 is 6, minus 6 is 0. So I have e to the 0 here is 1, which will equal positive 1. So that means I do not need the negative. That will just be my final equation with y isolated. Okay, moving on to number 8. Yes, number 8. This one is a little tricky to separate the variables because I can't have a plus p here. That's not going to work. So I'm going to subtract p. Normally I always say you can only multiply or divide, but I can't differentiate it like this. So I'm going to start by doing 10 minus p. Okay, now I can divide. So I can divide this to get, because this p needs to be on the other side. So I'm going to end up with dp divided by 10 minus p equals, and then I'm going to multiply the dt because I want that on the right-hand side. Now my p's are all over here and my t's over here. Now normally I would say leave on this side as much as you can, but I am not going to be able to differentiate it this way. Like, it's just not going to work. So, because I would have to multiply this by dt and then I'm going to be stuck. So this is as best as I can do to get it isolated. Okay, so to differentiate this side, to do the antiderivative here, notice for my u, this is going to end up with a negative. You should be able to see that du dp is going to be -1, which means I'm going to have a negative that's going to kick out front. So this is a denominator, so this is going to be natural log, but I'm going to have a negative that kicks out front. So this is going to be negative because of this negative. ln of my u, which is 10 minus p. So I kind of skipped them some steps there. Equals, and then this side, because there's nothing there, we can always imply that there's a 1 there. So that gives me just t plus c. Okay, now I'm going to plug in my value of 0.4 because I want to figure out what c is. So negative natural log of 10 minus 4 is 6, and this will be 0. Okay, so c is negative natural log of 6, so I can plug that into my equation now. So I have negative natural log of 10 minus p equals t minus ln of 6. Okay. We now are trying to get p by itself. So in order to do that, well, first I want to get rid of this negative, then I'm going to get rid of this natural log. So to get rid of the negative, I'm going to multiply everything by -1. So that gives me ln 10 minus p. That will be a negative t and a positive natural log of 6. Now we're going to raise this e to the power to cancel out that natural log, which leaves me with 10 minus p. Remember that this right here is going to kick out front because, and I need a scratch paper because I'm running out of room here. Let me demonstrate this property for you. Remember that when we have x squared times x cubed, we add up our exponents to be x to the 5th, okay? This is the same as x2 plus 3. That's essentially what we have right here. This is e to the negative t times e to the ln of 6, right? I would add these together and I would end up with this, okay? So when I do e to the ln, that cancels and I'm just left with a 6. So when I rewrite this, this is going to be 6e to the negative t when I simplify that. Now I'm running out of room, so I'm just going to kind of, oh, maybe I could do my steps over here. So now I'm left with 10 minus p equals 6e to the negative t. I can't drop those bars without checking to see if I need the plus or minus on this. So the initial value was 0.4, so let's just check that real quick. If I plug in 0 for t here, e to the 0 is 1 times 6. 10 minus 4 will be 6, so we need no plus or minus. We can just continue solving. So I'm going to subtract the 10 and divide by the negative. Negative 6e to the negative t plus 10. I multiplied everything times negative 1 here. Okay? So that should be your final answer. Okay, number 9. These are our rate in, rate out problems. This one would be a no calculator one, and then I'll show you a calculator one later on in the review. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. You should read that as an initial value. If BT is the weight of the bird in grams at time t equals days after it's first weighed, then we have dB over dt equals this. Oh, they gave us the same initial condition right there, kind of repeated that information. Use the line tangent to the graph of B at t equals 0 to approximate B of 3, the weight of the baby bird at time t equals 3. So you should read this. Line tangent is another way of finding the equation of the line tangent to the graph. So we already have our point. They gave that to us. SOT, remember this is the slope of the line. So they're giving us the equation. We just need to evaluate it at 0, 20 because we're finding the line tangent to the graph at 0, 0, 20. So I'm going to plug in 100 minus, B is my numerator, so that's like my Y value there. So this is like my Y value. So I'm plugging in 20 right here. So 80 minus 5, divided by 5 is 16. So now my EOT is Y. I'm going to do it in terms of B and T to be consistent with this problem. So my Y is like my B minus 20. My slope is 16. T instead of X minus 0. So I don't need a 0. Okay, so that's part 1, was to find the line tangent to the graph at B. Now we're going to use it to approximate B of 3. So 16 times 3 plus 20. So that's 48 plus 20 is 68. Okay, so that was part A. B, write the expression for d2b over dt squared. So this means find the second derivative in terms of b. So that means my answer has to have only b's and t's in it, and you'll see what I mean in just a minute. Then use that to determine whether the approximation is an underestimate or overestimate for the actual value that we found here. Give a reason for your answer. Okay, so part 1, we're going to find the second derivative. So I'm starting with this because this already gave me the first derivative, so I'm doing the derivative of this. Now instead of doing a product rule, I find it easier to distribute here. 100 divided by 5 is 20 minus 1/5 b. It's just a little bit easier to do the derivative of that form because the derivative of that is 0. Derivative of this is negative 1/5. The derivative of b, dB dt. That's the part that everybody forgets. Remember, when we take the derivative with respect to other variables, like we're doing the derivative of b with respect to t, we have to make sure and record that down. Now, I found the second derivative, but the problem is it says write it in terms of b. So I'm not done yet because I have this in here instead of just b. So I need to take this and plug in dB dt so that it will be in terms of b. So to do that, this is just going to be 20 minus 1/5 b. Okay, now we have a second derivative in terms of b. If you decide to distribute this out, you can, but keep in mind we've now answered the question. You don't have to go any farther than that. But we do need to answer the second part. Is this going to be an underestimate or an overestimate? Okay, so what we want to know, because when we have the second derivative, remember that if it's concave up, it's going to be an underestimate. If it's concave down, it's going to be an overestimate. So we just need to know the concavity, which we can find from the second derivative by knowing if it's positive or negative at that value. So I'm going to evaluate it at 0, 20, because that's what our equation of the tangent line was evaluated off of. Now, I could plug it into either one. I'm going to choose this one just because I already know this value. I already did dpt at 0, 20. It was 16. That way I just saved myself some math here. You could totally plug it in 20 here and you'll get the same thing. I just look how much the math is already done for me there. So this is negative 16 over 5, which of course is less than 0. So this would be overestimate of b of 3 because my second derivative is less than 0. Okay, last part, part C. This, of course, would be a free response style of question. You should be able to do these thoroughly to get all the points. So on your points on this one so far, you would get a point for your slope, your equation of the tangent line, and then your estimation. That would be 3 points. This one, you would get 1 point for getting your second derivative in terms of b. And then your second point would be this calculation saying it's over or an underestimate. Part C. Use separation of variables to find y equals b of t, the particular solution to the differential equation with this initial condition. Okay, so to separate the variables, I'm going to go back to this one because this one is going to be harder to separate. So I'm going to divide this to the other side to get b's. But I want to leave the 1/5 over here because remember it's helpful if you can leave as much on the right-hand side as possible. And I can leave this 1/5 here. So I'm going to kick this problem off by doing db divided by 100 minus b. Okay, you get your first point if you have all of your b's on one side and all of your t's on the other side. If you were able to correctly separate the variables, you earned your first point. The second point is, can you do the antiderivative correctly? I already see that I'm going to need a u sub here, and I can see that when I do the derivative of this, it's just going to be a negative that's going to bump out. So I'm going to remember to have a negative out front, and this is going to be an ln over my u, which is going to end up being this. To do the antiderivative of this, I'm going to raise it by 1, and then plus c. So that would be the antiderivative. That would be your second point. The third point would be, can you find c? Well, we're going to plug in 0, 20. So 100 minus 20 is 80. And that would be 0. So my c is negative 80. So that would be your third point if you solve for c. The last point would be, can you solve for b? So I'm going to go back to this equation. Minus ln of 80. Okay, I plugged my c in here. And if I can isolate b, then I earned my fourth point on this problem. So I'm going to multiply by negative 1 first to get rid of that negative. Okay, so I multiplied by negative to get that, multiplied by negative to get that. I need to get rid of the natural log, so I'm going to e both sides. So that will cancel that, and I'm just left with 100 minus b. This is very similar to what I just did in the last problem. Do you see how this is going to cancel and the 80 is going to multiply out front? Exact same reasoning as I did before. And then this will be e to the negative 1/5 t. To get rid of my bars, I need to see if I need to do a plus or minus here. So when I plug in 20, I'm going to get 80. When I plug in 0 here, e to the 0 is 1, so I'm going to get 80. So I'm not going to need the absolute value bars. They're not going to affect this problem. So I can go ahead and subtract 100 and divide by the negative and have my final solution of negative 80 e to the negative 1/5 t. And then when I subtract the 100 but then multiply by the negative, I'll get positive 100. Okay, skip a couple down to number 12. You notice we've done a lot of these kinds of questions, which means there's going to be a lot on this test, so really feel comfortable about these steps. There's 4 steps. The first step is, can you separate the variables? Can you get the y's on the left and the x's on the right? This one, I'm going to have to multiply and then divide. So how it's going to end up is dy over y minus 2. And then when I multiply and divide, this is going to be dx over x squared. Okay. Now I'm going to do the antiderivative, but I want to rearrange this a little bit so it's a little bit easier. I know this is going to be 1 over y minus 2. And this I should rewrite as x to the negative 2. To keep in mind that that exponent's negative 2 there. Now I would need a u sub, but when I think about my derivative of this, it's just going to be 1. So I'm not going to have any multiplier that's going to pop out front. So really I can just keep in mind this is going to be an ln with a u in there when I do my antiderivative. Raise it by 1, divide by that number, plus c. Okay, now we're going to plug in our initial condition to solve for c. So when I plug this in, this is going to be negative 1, but the absolute value of negative 1 is positive 1. The natural log of 1 is just 0. Remember, e to what power is 1? That's 0. I'm going to plug in negative 1 here. So let's see. I have to do the exponent first. Remember that when you have a negative exponent, this is the same as 1 over x. And I'm going to plug in that negative 1. So this is negative 1 times negative. So that's going to end up being positive 1. And then when I subtract it, I get negative 1. Okay. Now we're ready to write our equation. ln, and I already demonstrated that this was 1 over x minus 1. Okay. My final goal is to get y by itself. So I need to get rid of this natural log. So I'm going to do e to both sides, which leaves me with y minus 2 over here. And this side will stay the same. This is all an exponent now. Need to check to see if I need to do a plus or minus here. So when I plug in, I'm going to test my negative 1 and 1. So that would be 1 minus 2 will be negative 1. When I plug in negative 1 up here, let's see, this will be 1. So that'll be 0, 1. This side's 1. So I am going to need to put a negative here. Right? Let's test it. I just added 2. I'm just going to check to see. So that's positive 1. So that's 0. So e to the 0 is 1 plus 2 is 3. So I definitely need to put a negative in here. Okay. So if I have a negative there, e to the 0 is 1. Negative 1 and 2 is 1. Okay, so I do need that negative in there. See how you have to check your point to make sure it works? You definitely need the negative. Okay, I'm going to skip down to part C on this one. For this, the differential equation here, to do your slope fields, remember you're just doing a positive slope, negative slope, or zero slope. So go ahead and just plug those numbers in there to solve for that. This means to find the second derivative. So you'll be finding the second derivative of this. Don't forget to do your product rule. So the first times derivative of the second plus the second times derivative of the first. So you'll be doing that one for that. The final one is the one I want to do one more time to make sure we've got the hang of this, because there's a lot of it on the test. So I'm going to divide by y cubed and multiply the dx. So first point is separating the variables. Step 2, antiderivative. Of course, keep in mind that this is y to the negative 3. So when I raise it by 1, it's going to be y to the negative 2 divided by negative 2. Raise this by 1 and then divide by it, plus c. Plug in your condition, initial condition, to be able to solve for c. Since this is a negative 2, I know this is really in the denominator. This is really 1 over negative 2 times my y value, which is negative 1. 2 squared is 4, divided by 2 is 2. So this is really 1/2. So when I subtract there, when I subtract 2, 2 minus 2, oh, I forgot my squared here. This is y squared. So that's going to turn that positive. So this is going to be a negative 1/2. Okay, negative 2 minus another half is negative 2.5. Okay, come back to my equation here. This is 1 over negative 2y squared. I forgot that squared the first time. X squared over 2 minus, it looks like these are going to be into a fraction, so I'm going to make this a fraction because it might help me simplify on the next step. So that should be negative 5 over 2. Because I can see that it's going to be helpful to multiply by 2. I'm trying to get y by itself now. So I'm going to multiply everything by negative 2 to cancel that out. So that's going to leave me with 1 over y squared. This one will be negative x squared, and this one will be positive 5. Okay, now I want to flip it. I would like the y squared to be in the numerator. You're allowed to flip it if both of your terms have the same denominator. Otherwise, you have to get a common denominator first. And right now, they do have a common denominator. It is 1. So I am able to just flip this to be 1 over negative x squared plus 5 because they already have a common denominator of 1. My final step is to get rid of that squared by square rooting both sides. And keep in mind, when you square root, you got to do plus or minus. We're going to have to check to see which one is the correct one by plugging in our initial condition of 2, negative 1. So let's see, if I plug 2, that's 4. So that's 1, and it's got to equal negative 1, so I need the negative in there to make it work. That's my final answer. All right, last page. Just a couple tips for you on drawing your slope field is be sure that you put a clear dot wherever you want it to be. So for example, if we want to do 0, 1, okay, 0, 1 is right here. Make sure you put a clear dot. And then when you draw your slope field, make sure you do it clear to the ends of the graphs. Before you draw it, though, look at your equation and see if you have any undefined values. So like nothing that would cause division by 0. We have no fractions here, so that's not going to be a problem in this problem. So all I have to do is follow the lines, and this one is just straight across, kind of boring. Notice I go clear to the edges. I don't put arrows. I just go edge to edge following the slope field. For this one, 2.5 right there. Okay, this one's a little more interesting to follow the slope line, so I can kind of see it's like going negative, and then it's kind of turning up positive, and then it's kind of flattening out and going negative again. Let's see what's going on this side. It's going up, kind of flattening. Pretty good guess. Write the EOT. You should read that as the EOT. So they already gave us a point. SOT, well, we have an equation for the slope here. We're evaluating it at 0 and 5/2. So I'm plugging that in for x and for y. So for y, I have 5/2 minus 1, 0 plus 1, cosine of 0 plus 0 plus pi. So I can just go ahead and make that pi. So 2.5 minus 1 is going to be 1.5. This is going to be 1. Cosine of pi. What is the x-coordinate over there? That should be -1. So this is -1.5 when I multiply those all together. Okay, so now I can write my EOT. Y minus 5/2 -1.5 x minus 0. And the final question. We've done these a million times, but we're going to do it one more time. This one looks like a crazy one, so let's see how this one comes out. So I want to get all my y's to the left, x's to the right. So this one is going to come over here, stays, stays. All right, let's see if we ended up in the same spot. So I had 2 of the factors here. I moved y minus 1 over here, and I moved my dx to multiply up here. Okay, we're ready to do our antiderivative. I'm going to have a u sub, but when I check this out, it's just the derivative's 1. So we're good with no multipliers popping out. I know this is going to be ln. In fact, I'll just do this side. Okay. This side, hoofda, I am going to need a u for this for sure, and I can't differentiate this at this way anyway, so hopefully when I do the derivative of this, it's going to cancel this, because otherwise I'm super going to be stuck. So let's see, I'm going to come up here for space-wise. My u, we're going to hope, is going to be x squared plus 2x plus pi. Take the derivative. 2x plus 2. Constant is pi. Okay. This is probably going to help, because when I isolate dx, remember I was saying I really need this to go away? Well, if I factor this, this will cancel that, okay? So this can cancel with that. It'll be on the bottom. I just have a 1/2 that's going to pop out. So here's what I'm left with. I should have maybe not done the antiderivative of this yet. So this is going to be cosine of u. So I have a 1/2 out front from there. We know that part. Antiderivative of this. So you're thinking SC, negative S, negative C. I'm at cosine. Antiderivative will be sine. So 1/2 of sine of all this mess. That was my u. Plus c. Okay, now we're going to solve for c by plugging in that. So when I plug in 5/5, so 2.5 minus 1 is like 1.5. So ln of 1.5. 1/2 sine of 0 plus 0 plus pi. So sine of pi, the y value over there is just 0. So this is going to be 0 times 1/2. That's just 0. So my c is going to be the natural log of 1.5. Okay, so we are ready to write our equation, which is this. Okay, I just wrote the whole thing with my c plugged in now. Final step is to get y by itself, so I'm going to get rid of this natural log by e to both sides of this whole mess. So I'm left with just y minus 1 over here. Let's see, I'm going to have e to all of this, e to the ln. Okay, so here's my multiplier that I can, so this is going to be 1.5 using that same property I talked about before. e to the 1/2 sine, and then all of this is still an exponent up here. Final step is to add 1 over here. I do need to check to see if I need the plus or minus here. When I plug in 0, this is going to be sine of pi, which we've already talked about as 0. So e to the 0 is 1. This equals 1.5. This equals 1.5. So I do not need to change my signs at all. Plus 1. Yay, we made it. Good luck on your test, guys.